Welcome back. In this video, I'm going to be focusing on a very basic concept, and that's classes. I'll also be touching upon how you would be defining the default constructor. So, the core idea behind classes is data abstraction and also encapsulation. So, what do you mean by data abstraction? Data abstraction is nothing but the separation of the interface from the implementation. So, you do not want the user of your class to actually get into the details of the implementation. All that you expose to the user of a class that you write is the interface. So with that, let me jump right in here. So I've written out a class here for an employee, a very simple class. So as you can see, an employee has a name. They'll probably have an employee number and the age and maybe the title. So by interface, I mean, the functions that the user of your class would be uh, using. So the actual implementation as to, how exactly this function has been written, that is abstracted away. So that is what data abstraction is all about. You don't want to give the user of your class the details of what you're doing. You just provide them with the interface. And encapsulation is sort of related to that. By encapsulation, you're encapsulating all the details and you don't really want to expose the details to the user. So you hide the details of the implementation. So that being said, um, let me go back to this class that I have written out here. So as you can see, these are called the member variables, and they're by default a class controls access to this, and the default control is private. So these variables cannot be accessed outside the class. And the next keyword that you see here is the public keyword. So this actually uh, tells the compiler that it should, expose these members to users of the class. So as you can see, there's a constructor here, and there's another constructor here, and then I've got a display function. So all these have public access, meaning to say that these functions, including the constructors, can be accessed outside the class. So I have two constructors here. So what's a constructor? A constructor is nothing but a function which initializes the object. So a class is nothing but a template, and when you create multiple objects, each object is going to be created using this template. And every constructors once again, they can be overloaded. I'll be touching upon overloading in a different video. So the constructor that you see here is known as the default constructor. Let me just annotate that. So the default constructor doesn't take any parameters. All right. So as you can see here, the latest C++ compilers support initialization of data members. So here I've initialized employee number to 0 and the age to 22. And my default constructor, which takes no arguments, I've just initialized only name and title. The default constructor, now the compiler knows that it should actually use your inbuilt, your in-class initializers to initialize the remaining two member variables. Now, in case you do not provide this constructor, the compiler will generate one for you. But if you want the compiler to do that, you shouldn't define any other constructors. So here, in this case, I've defined another constructor, right? So let's say I remove both these constructors, all right, and let me comment out this code. And as you can see, this code will still compile. Okay, as you can see here, it succeeded. That's because, so I'm trying to create an object of type employee. So that's what I'm doing here. So I'm creating a default. I'm creating an object of type employee. And to create that object, you need to call the constructor. Now, we are not written out any constructors here, but how is it that it's able to create an object? That's because the compiler generates a default constructor for you. All right, so let me put this back. However, remember that if you want the compiler to generate a default constructor, you should not provide any other constructor. You shouldn't write out any other constructor. All right, I'll leave that to you to try out and play around with. Now, let me focus on the second constructor that I have provided here. So this is a constructor, a parameterized constructor, which tries to initialize all the member variables. So as you can see here, the constructor is passed the name, the number, the age, and the title. All right, and what you see here, there's a colon followed by all these variables being initialized. This is something that's called the initializer list. And it's recommended that you use an initializer list because that gets executed even before you enter the body of the constructor. So in this case, the body of the constructor is empty. So we have two constructors here which can be used to uh, what can I say, initialize objects and create objects. And then I have another function here, the display function, which is actually used to inspect the contents of the object. So this is the third uh, function which is being exposed as part of the interface. So this entire class is an abstract data type. It's a data type that you have defined. So you have defined a data type called employee, and this is the signature of that data type. So now, as a user of the class, you can create an object of that type and called interface functions on it. So as you can see here, I've defined two objects, E0 and E1. So E0 uses the default constructor and E1 uses the other parameterized constructor. So I call display on both of them. Let's see what happens. Let me build it. Awesome. As you can see here, the first one is which uses the default constructor. So name, we didn't supply any name, so it's blank. The number and age, of course, take the initializers that were supplied as part of the class. So I'm referring to these initializers that were entered as part of the class definition. So that's what is output here. The title, we did not supply any title. As you can see, I've just only created an empty string here, a name and title. So that's why you don't see any content here for the name and the title. And the next employee object, I've supplied parameters, and that's what is displayed here. So that's awesome. Now, there's one more thing that you can do today. You don't really, so for instance, the default constructor is usually not used to do anything special. So you could always ask the compiler to help you out. And today's compilers support this, where you just need to say, you're telling the compiler to generate its default uh, constructor. All right, so you don't need braces here because that's unnecessary. So all you're telling is you're instructing the compiler to generate its default uh, constructor. And now the compiler knows that it should use the very same initializers that you have already provided here. And for built-in types, say for a string, it's default initialized. So a string by default is initialized to the empty string. So let's run this again and see what happens. As you can see, we get the same. And ourselves a little bit of typing by using what the compiler supports. You can use the default keyword. So This is in short, what the classes are about, and what the constructor can do for you. As you can see, I've defined all the member function display within the body of the class can always be defined outside the class. And how do you do that? You supply the return type and you say employee now displays a member of employee, and you just need to take the body of the function. Let's remove this. Okay, and so I have a declaration there in the class, and I have defined the function outside the class. All that you need to do is you need to tell the compiler that display is a member of the employee class, and for that we use the member operator here. All right, so let's run this and see what happens. As you can see, we get the same output. It's all gone through. So this is how you define the the member function outside the class. And there's one more point that I would like to bring up here. Just give a short introduction to it. Now, when you call e1.display, you're calling the function, the member function on this e1 object. So there is something called the this pointer. Okay, this is nothing but the address of this object, e1. All right, and this pointer is passed implicitly to the display function, because how else does the display function know that it has got to display prob and 205 and 32, and in this case it displays a blank string? How does this display function know that? It's because it's passed some information about the object, and that information is implicitly passed. You don't have to explicitly pass a pointer here, but that's implicitly passed to any member function. So I could have maybe another function tomorrow which says, say, void, let's say, set, or uh, let's say list of names. Say, let's say I have another function like this. I'm another member function. So in all these cases, this pointer is passed implicitly, and this pointer is nothing but it points to the actual object on which this function is called. So please bear this in mind when you talk about um, classes, objects, and member functions. That's it, folks, and I'll see you in the next lecture.